I'm going to do a deep dive now into Project Aria. I'm going to give you some updates on Project Aria and also some exciting news about Aria Gen 2 that I think a lot of people have been waiting for. So Ray-Ban Meta has been a great commercial success with now over 2 million devices sold since its debut in 2023. And we're now beyond what we would call a minimum viable product. And we're expanding functionality with devices that have displays, even more immersive prototypes that you've probably seen in some of Mark Zuckerberg's announcements in the past that are not shown here. So really we're expanding. And there are great experiences that are being developed on these devices that we're certain will essentially bring the next major wave in computing. They leverage LLMs and VLMs, which are amazingly able to summarize much of the internet when asked the perfect question, when summarized in the perfect way. But there's still the problem of doing that summarization and providing these models with the context that they need to be useful. And we're also at an inflection point in robotics, where we're now able to use human data to train robot policies. LLMs and VLMs are evolving into vision language action models, and robots can act directly from what they perceive. And glasses and robots perceive the world from their own perspective, and that's what we mean when we say the egocentric perspective. This is, after all, the egocentric tutorial. And it's really the embodied human perspective is one way we can think about the egocentric perspective. And in order to train these vision language models, vision language action models to operate in domains where they can offer value to us, they need to be trained with data that represents what we experience as humans. As you can see in this example, this is the hot 3D data set. I still think it's a very excellent example that just illustrates what egocentric data can be. We have the person's gaze indicating what they're focused on. We have what their hands are doing, hand-object interactions. This is all in 3D space. I think this is a very good summary of what egocentric data means. And as a community, we're asking critical questions about how much data like this is needed for breakthroughs in performance in training vision language models, how specific that data needs to be, how to formulate data sets that are effective for training and benchmarking. And I think we're coming a long way. Every time we have a tutorial like this, we see new advancements. So this leads to the mission of Project Aria, which really is to bring the human perspective to AI. AI is mostly about bringing internet information more effectively to humans right now, again, given this manually constructed context. But this is where we need to start thinking about a shift, about how we bring everything in our embodied human experience through multimodal sensing devices to AI systems so that they can better understand us and be massively more helpful to us. Over 290 research partners in 27 countries now use over 1,000 Aria Gen 1 devices. And these are the top computer vision, contextual AI, human-computer interaction, and robotics labs and companies worldwide. We now count 600 citations of Project Aria and Aria dataset papers, spanning a breadth of publications that focus on the evaluation of vision language models with egocentric data, to new innovations in robot training methods and foundation model development. And just earlier this year, we announced Aria Gen 2, our latest hardware with many improvements. We are working hard to make Aria Gen 2 available to the community in Q2 of 2026, and applications are open today for Aria Gen 2. I'll give a QR code at the end of this talk where you can go to a blog post that has all of the information that you need to submit an application for Aria Gen 2. I'll go into some exciting details about Gen 2 so you can start to formulate a picture of how this is going to work for you. So Aria Gen 2 provides a step change in usability and capability for the egocentric research community in several dimensions. It's more wearable with eight different sizes to accommodate various human factors. There are significant upgrades to the sensor suite. It has on-device real-time machine perception and audio to enable interactive experiences. So here's a view of the diverse sensor suite with an RGB camera, 4 computer vision cameras to capture a broad field of view, eye tracking cameras, IMUs, a magnetometer, a barometer, 7 spatialized mics, a contact microphone, a health sensor, PPG sensor for heart rate, a global navigation satellite system, and a time alignment radio. We are invested massively in sensor calibration, both at the individual sensor level, across sensors, and even across devices. And you'll see that this is a very difficult problem. We have calibration stations here for CV and RGB cameras, the microphone and speaker system, and our eye tracking cameras. And calibration is fundamental to sensor performance, especially for things like multimodal sensor fusion. Not only do we do what we call factory calibration before shipping these devices using systems like this, but we also offer what we call an online calibration for each recording that's sent to our SLAM processing algorithms that you can use. And I want to show you why this matters. So here we have a view of a high-speed camera showing a drop test of Aria Gen 1 glasses. And you can see extreme deformations of the glasses actually in this high-speed view. And these deformations can result in relative position changes of the sensors dramatically. This is an extreme view, but you can imagine even just wearing the device through thermals causes deformations like this. And here's a view of the glasses actually streaming sensor data to the NVIDIA Foundation stereo model for depth computation. And we're kind of purposefully bending the glasses as we're doing this. And you can see what a large result it has in deforming the depth result. So this is just a view of how downstream applications are affected by these deformations and why calibration is so important. Here we have the most sensitive application that we know of yet for these kinds of calibrations, which is a scene reconstruction. And we have a Gaussian splatting reconstruction. And this is the kind of thing that can only be achieved when you have online calibration, which we perform on each of these recordings. And if you look on the left, you can see the factory calibrated result is good. You can tell what it is, but it's not immersive. It's not fully realistic in the way that on the right, if you see the online calibrated result, you'll see the details in the trees, you'll see the spokes on the bicycles, and you'll see these cables being represented very realistically for 3D immersivity. And then the other thing that we spend a lot of energy on is, just as Richard pointed out with this idea of having multiple devices able to reconstruct a shared reality, you need to align sensors in time, so multiple Aria devices in time. And you can see on the left, without time alignment, the top and bottom two recordings, if you look on the left, the top and the bottom, if we really zoom in time and space, we can see a manual attempt to align these things is kind of pretty wonky. And when you get into trying to reconstruct at the multi-device level, it makes a big difference. With the time alignment that we've invested in, you can see very, very high level of detail on the right, almost perfect matching. And we can even measure this sort of thing. What we basically do is we have a special radio that facilitates transmission of the recording timestamps between the devices, and it's almost negligible. It's down to a 10 microsecond difference when we use these timestamps. And we can see that in some of these testing tools, these time measurement tools. Another thing I want to get into is just the quality of the sensors themselves. If you look at the computer vision cameras, which are a custom computer vision camera stack, the CV camera features 4.6 micropixels in a 512 by 512 array and employs an overlapping triple quantization scheme to enable single frame, single exposure, high dynamic range imaging. And the dynamic range exceeds 110 decibels. And what does that actually mean? If you look in the top left at the computer vision camera and you see the light turning on, you can actually still make out the filament, even in the midst of the bright exposure of the light. And you can also, at the same time with this high definition camera, see the background lighting. You can see the trees. So it's a really great achievement here. And the other thing, not just the high definition of the camera, but also the number of cameras we have and their spacing allows for us to achieve a very large field of view, both out to the side and down, as well as a large stereo overlap. And the large stereo overlap now lets us do amazing things when combined with something like NVIDIA Foundation Stereo, which Michael and Bowen will be speaking about later. And by the way, we're also going to have an awesome live demo of this at our booth and a little bit later today, where you can actually use the system as an effective depth sensing head-mounted tool. So there's another way to look at the features of the device other than through the sensors, and we can look at it through a view of its interactive capabilities. So here we have a view of the basic ways that you can interact with the device. We have an action button for turning on recording, for example. The basic things like power and status. There's also a privacy switch. If you encounter a situation where maybe you did not have a consented person in a recording, you can flip the privacy switch and turn off the recording immediately. We have volume controls. You can connect the device to a Bluetooth audio source. You can imagine that audio source being something that's providing some kind of feedback to you. If you have the device connected up to a model. We have a contact mic. You can speak to the device. Let's say you have an LLM running in the background. You can actually set this up in a streaming way to speak to that LLM. And you can imagine all sorts of things. Maybe you're having it computing bounding boxes for you. You have some audio feedback. You can get extremely creative with the device.
You put the glasses.
I'm just going to show a video of a case study that we did with the company Envision, who focuses on solutions for the blind, to show you what I mean by audio interactivity.
You put the glasses on and you just talk to it like you talk to a friend.
Hey, Meta, help me pick up some apples.
Certainly. Follow the sound to locate the apples in the store.
It'll start playing a beacon sound from the location within the store.
The glasses can actually map as they are being used.
We can allocate different points and label it with items that should be there in that space.
Apples are here.
You put the glasses on and
then another thing I want to show you, and actually I just want to pause for a second, talk about that demo a little bit. So actually Chungpung's going to give a demo of the client SDK and some of the ways we can build interactive experiences. And you'll see a little bit about what's under the hood when creating an experience like that. And you can think a little bit about what you would do when you watch him going through that demonstration. Now, the next thing I'm going to show is actually a view of our contact microphone, which is able to pick up audio by actually connecting physically and picking up vibrations, which can distinguish from ambient audio if you're in a noisy environment. So now you can imagine you're trying to speak to the device in a crowded space, and you can pick up your own audio much more clearly than the ambient audio.
Compared to Aria Gen 1, Aria Gen 2's unique
You can hear the wind kind of overriding all the audio here, but with the contact microphone on, it's able to pick up the audio more clearly. Okay, so I'm going to switch frames yet again to talk about the device in the context of a very large advancement from Aria Gen 1, which is on-device machine perception. And Meta's developed a specialized custom coprocessor that also interoperates with a Qualcomm chip to achieve on-device machine perception. And for dataset creation, you can save enormous effort in long-duration recordings where MP signals get included directly in your recordings. And it also opens up the possibility of using the signals in real time. The Aria Gen 2 device has the ability to perform automatic speech recognition on the device. And this is an overview of the kind of data that you can get in real time from the device. We currently have hand tracking and VIO, visual inertial odometry, basically trajectory computation, running in real time on the device. And we're generally accelerating our process for how we, what you would call, lower an algorithm onto the device. And we're experimenting with all sorts of algorithm lowering. For example, like a hand-object interaction model, potentially lowered onto the device. And we're actually very open to ideas of what you might want to see lowered onto the device and potentially available for on-device computing. We're really open to conversations about that if you have ideas of what would be useful to run on-device. And when we provide Project Aria to qualified partners, we don't just provide glasses. We actually provide the Aria Research Kit. And the kit is more than just the glasses. It's a comprehensive set of tools for creating data sets and prototyping experiences. And at a high level, Aria Research Kit is composed of the Aria glasses, a mobile companion app, a client SDK, machine perception capabilities, and tools for working with Aria data. And we've observed that the community has two primary use cases for Aria Research Kit, and those are dataset creation. We now have a huge proliferation of externalized open source datasets from our community. Also, of course, from Meta, we also produce our own. And then also interactive prototyping. I showed the Envision demo, but you can imagine all sorts of things you might interactively prototype. And we foresee the community moving further and further into developing interactive prototypes once you have, let's say, a trained model and you want to run with it real time. So now I'll just dive into the companion app a little bit, which you can think about as a remote control for your device. And it offers a lot of functionality. You can pair your glasses, you can manage recordings. There's the concept of what's called a recording profile. This means if you have a certain set of sensors that you want to use in your data set creation or your streaming, and you want to run them at a certain frequency, let's say you want to run the RGB camera at 30 hertz, you want to run the CV cameras at 60 hertz, you want to use the microphone, you can turn on all these things at the right frequency to optimize power usage and to optimize for the size of the files that you create. You can set those in the companion app directly. And you can see a live preview of the sensors that you're using before you start recording, get confidence in what it is that you're going to be recording. And then another new thing that you can do in the companion app that Gen 1 users might be really excited about is you can rage shake. So you rage shake the device if you're having a problem, and then very quickly you can type exactly what your bug is, and you can communicate directly with user support in this very streamlined way instead of writing an email, for example. So you can just get it out there real time. And another way of interacting with the device, actually the most complete way of interacting with the device, is through the client SDK. And the client SDK is a comprehensive toolbox that will facilitate control and interaction with the Gen 2 device. You can manage the device, you can start recordings, you can stream with the device, you can record. We have Python and CLI tools for working with the device, and a whole bunch of example code for how to work with the device. And another great thing, again, is you can do this kind of interactive experience creation using the SDK, where you're streaming the sensors and machine perception signals to a PC or some back-end system. And then you're controlling the device and you're getting audio feedback or TTS feedback. So you're actually interacting with the device, as I showed in the Envision demo. So now I'm going to segue to talk a little bit more about machine perception. Aria Gen 2 can compute signals on device. I already showed you that in the device overview. But yet more can be computed in what we call machine perception services, which is an offline way for richer computation. And here you see some results from our machine perception services. We can compute hand tracking. We can compute also a closed loop trajectory. We can compute semi-dense point clouds. And I want to show a stunning example of semi-dense point cloud computation from the Lamaria dataset, which was just discussed, a dataset that ETH Zurich led. This is actually entering a tram, and you'll see the trajectory of this person entering a tram. You'll see all the semi-dense points, and they're color-coded from the observation. Basically, you'll see colored points at the time of observation when the glasses saw those points. And I think it's just stunning to see the length of the trajectory that's computed over the course of this tram going down a hill. And you're sort of seeing the zooming out. You can see the duration of the trajectory computation and the scale of it. And what's actually amazing is just the small amount of drift that occurs over this very large calculation. And you can see in the leftmost images, what you actually have is the computer vision cameras, and you can see the observed points happening, reprojected into the computer vision cameras. So really stunning example of our SLAM algorithms in action. And then you can see them actually getting off the tram. So this is one of the most impressive visualizations I've seen of our SLAM system yet. Okay, so not only can you compute a single trajectory, but over the course of months or longer, you could compute many trajectories in a shared space. And then you can compute you can compute a map of all of those, and then you can do a bundle adjusted SLAM calculation from all of these over time. And this, I think, is actually done over something like 20 or so recordings, computing one of our meta buildings. Okay, so I'm going to shift from SLAM onto a different topic and talk about hand joint pose computation. This is our 21 key point output computation. And this is something we made available a few months ago, and roboticists in particular have made great use of for articulate hand joints. And we now have an update coming out tomorrow in the MPS system to have more accurate hand joint computation in two ways. So the update that we will have will result in a reduction in loss of hand tracking. That means if you have a frame where previously you may have dropped hand tracking, you can see that in the top 3 images, there's a dropping of hand tracking. We'll have a great reduction in the loss of hand tracking. And then for the individual key points, and this is my best way to show you, if you look in the left, this is from the Hot3D data set, you can see the divergence from ground truth. So ground truth is kind of captured with mocap, and then we do our calculation of the hand joints. And you can see the divergence from the ground truth with the previous hand tracking algorithm. And so just keep an eye on how much the light blue diverges from the dark blue and the orange diverges from the red, as an example. So keep that in your memory. And now I'll switch to the new one. In the new one, you can see it's almost perfectly aligned. There's much less divergence happening. So this is a massive improvement in the quality and accuracy of our hand tracking, which again will come out tomorrow if you're already using Aria Gen 1. So Aria Studio is another tool that you can use to interoperate with Aria. Aria Studio is a desktop tool, and it's a great way for you to take recordings that are on your glasses and then download them onto your local machine and then submit jobs to the machine perception services to have offline computation. And you can see that workflow happening here. You can manage your recordings. You can request SLAM computation, for example. You can look at the result of a job. You can then even double-click and visualize the result of your recording. And so some folks may be already familiar with using this tool. And there's something I want to mention is that we have an update to Aria Studio that was just released in Aria Research Kit v1.15, which was announced, I think, yesterday morning or maybe the day before. So Aria Gen 1 users can now directly, if they have an issue with an MPS job, they can, after requesting the job and seeing some kind of issue, communicate with our user support directly from Aria Studio. So you can submit a case and say, hey, I'm having an issue processing this job. Can I get some help? And then we'll know exactly what job it is that you were having issue with, and we'll be able to work with you very rapidly over Aria Studio. It's a great advancement. And then we have EgoBlur for anonymization and data privacy. We're very privacy forward. And we've made this available for Aria Gen 1. And likewise, we're going to have this also for Aria Gen 2 once it becomes broadly available. Okay, I'm going to switch gears to talk about Project Aria Tools. Project Aria Tools is the way that you work with Aria data. So Aria recordings are made available in what's called a VRS file once you have them on your local machine. And this is a container that sort of houses multimodal data, and it has all of these different streams. You have your machine perception output stream, your audio stream, your computer vision camera stream, etc. So it's a very large sort of container for all your data, and these can be multiple gigabytes. And we've invested a lot in ensuring that you can have fast random access and iterators over this data, and powerful Python and C++-based visualizers of the data. So this makes it very convenient to work with VRS data. And actually, when we get to looking at recordings, Arya Kang is going to go through some examples of how to use Project Aria tools. So that was Aria Research Kit. I hope I gave you an overview of everything that you can use within Aria Research Kit. And I'm going to talk about some open source data sets and models that we have. And the biggest announcement that I have for you is that we have the Aria Gen 2 pilot data set. And this is a brand new data set. This data set is available for download immediately. You can go on our website and I'll give you a QR code where you can download this data set. I recommend that you do. This is one of the best ways to get familiar with Aria Gen 2 and the kind of data that it can output. We have all the sensors being recorded available to you. We also have all the machine perception output available, recorded from the device. We also have machine perception recorded from machine perception services. And it basically follows a subject through a hypothetical weekend of activities, doing things like walking, cooking, playing. We tried to capture a diverse range of activities so that you can see what the device is able to compute in all these different scenarios. And then a really cool thing that we also included here is the output from algorithms, including bounding box detection from our egocentric voxel lifting algorithm. We have also diarization, ASR, basically speech diarization, and heart rate estimation. And we also have depth from foundation stereo included in this output. So it's a very rich data set. And another thing is it's computed from multiple Aria devices simultaneously that have been time aligned. So it's a great data set for you to get familiar with what the device is capable of. And then other new things coming out now is Lingni's going to talk in a little bit about Nymeria++, which is an advancement to the Nymeria data set that was released at ECCV in 2024. And this year, Nymeria++ upgrades the data set in different aspects, including optimized human motion. And the latest models from Meta retargeted into SMPL for academic usage. And I'm just having some trouble with my video. It's not quite loading. Might be too large. I think I'm running out of RAM here, but Lingni will have a way better visualization of it as she goes through. And then Yowar will also present Shaper, which is a novel approach for conditional 3D object shape generation from casually captured in the wild sequences. And given a sequence, it leverages off-the-shelf SLAM pipelines to extract sparse point clouds and 3D detection algorithms to obtain for each object a set of SLAM points, pose multi-view images, and machine-generated captions. And a rectified flow transformer is then trained to effectively condition on these modalities and generate high-fidelity metric 3D shapes. So two drastically different releases, one around human body motion estimation and another around environment sort of estimation and reconstruction. And we also have all of our other data sets and open models. We have, I'm just showing several here that are generally categorized as object and environment reconstruction data sets and models. And then also models around people in their environments, so largely around the mission of what Richard described we're trying to achieve. And then some recent community highlights people will be talking today. We have ETH Zurich's Ego PPG, which really looks inside the wearer and understands things about what's going on both inside their psychology and their biological systems. We have the Lamaria data set, which is an outstanding benchmarking data set for city-scale SLAM. We have Georgia Tech's work on mobile robot manipulation, which is a new data set. And then we have Ego XOR from TU Munich, which is showing Aria in the operating room. It'd be really interesting for us. And I just have to show again, Anusha created this from the Lamaria team at ETH Zurich, a visualization from Lamaria going through the city of Zurich. I think it's just really impressive result, showing the trajectory visualized. I'll let that play. Yeah, I encourage everyone to download Lamaria and think about how to work with a benchmarking data set like this. These are all the Lamaria trajectories now shown live, covering a large swath of the Zurich city center. Okay, so what's next? The important stuff that you need to remember as you walk away today. Aria Gen 2 applications are open now. you can submit an Aria Gen 2 application now. That's both academic and corporate researchers. If you filled out what was an interest form, that was like a very lightweight form that we had basically since we opened up and announced Aria Gen 2, you still need to fill out an application. Applications contain way more detail than an interest form, and we need all of that detail to really triage the application. So please fill out a formal application. And Gen 1 applications are closed now. We're no longer taking Gen 1 applications. It's all Gen 2. If you submitted a Gen 1 application, we're still going to process that backlog. We'll get back to you. And we'll do that as soon as we can. And we'll still hand out Gen 1 devices for those that have filled out an application and qualify. And then if you're an existing Gen 1 user and you want to transition to Gen 2, you have to fill out an application still. And we're going to ensure a smooth transition for you. So we'll work with you on timing. We'll make sure we don't interrupt your ongoing research. And Aria Gen 2 is planned to be broadly available targeting Q2 2026. That's the current specificity I can give on timeline. And I'll continue to update people on timeline as we get clearer on exactly what those dates will look like. So this is your QR code that contains all of the information that you need. Yep, please take this as a recording. This is going to link to a blog post on the meta.com blog, which highlights for you links to the Aria Gen 2 device white paper. Goes into great detail on what all the sensors are, what they're capable of, what the device is all about. It gives you links to the application forms. It gives you links to the Aria Gen 2 pilot dataset where you can download the dataset. And it gives you links to the documentation where you can learn in detail about Aria Gen 2. So that is your main source of information. Okay, and so I've gone through, the highlight of Aria Gen 2. Now it's time to make this the hands-on tutorial that it is. And I'm going to pass things off now to Aria Kong, who is going to talk about recording and how to do a recording workflow. All right, Aria, come up to stage.